Hello everyone. In this video, we are going to see the part C of your practice exercise 2.1 where we have to calculate what is that vector q at point T in all of the three coordinate systems. So what are that three coordinate system? We have that rectangular one, which is what we are given with for that vector q, and then we have to calculate what is that vector q at point T in its cylindrical as well as the spherical coordinate system. So we have evaluated, we have found out that what is vector q in terms of its cylindrical format and in its spherical coordinate systems in our previous two videos. So I am going to put that link for that previous two videos in the description box. You can go through that one. And for this video, we are going to evaluate what is that vector q at point T for that rectangular one, for its cylindrical form and for its spherical form. So very firstly we will start with what is given to us, and then we will find out what is that vector q in all of the three coordinate system. So we have that vector q in its rectangular form. Now very firstly we are going to evaluate that vector q at point T. So what is that point T? So very firstly we are going to write it down for its Cartesian system or rectangular system. These are the one and the same thing. Okay, so Cartesian or rectangular. So for that Cartesian or rectangular system, what we have? We have that point T having the coordinates 0, -4 and 3. Okay, so what is that vector q? So we have to put the values of that x, this y and z within this given vector q in order to find out what is that vector q in its Cartesian or rectangular form. Okay, so very firstly we are going to put that values, and then we are going to calculate that one. What is that vector q at respective points of 0, -4 and 3. So put that values, rewrite that one. So we have that vector q which is square root of x square plus y square. So what is the value for that x square that we have over here? We have that x to be 0. So that will be 0 square. For y we have that value to be minus of 4 square divided by square root of x square plus y square plus z square. So again that x is 0 square, y is minus 4 square, and z is we have 3 square, that too taken in the square root. Then this ax cap over here, then minus y is again minus 4, z is your 3 which is given value over there, again square root of that 0 square which is x square, y is what, minus 4 square, and z is what, that is 3 square, that too taken in the square root, and here we have that az cap. Now simplify that one. So this is very much simple. If you are going to simplify that one, you will find that vector q at point T which is of 0, -4 and 3. So that is equals to this square root of minus 4 square is what, 4, and this denominator, so 4 square is 16, this 3 square is 9, so 16 plus 9 is 25, square root of 25 is what, 5. Sorry, okay, sorry, something typed, something I have mistaken. Okay, so we have that 4 divided by 5 ax cap, then this minus 4 into 3, so that is minus 12, and this minus, so that will be what now, that will be plus 12 divided by this denominator, so it is again what, that is 5 az cap. So we have that vector q is equals to what, so we have the value for that vector q to be 0.8 ax plus 2.4 az. So this is what is your vector q at point T in its Cartesian system at T is equals to 0, -4 and 3. So this is your answer for the very first part. We have expressed that vector q in its rectangular form at point T. Now next we will move on to the second part of the C1, which is what we have to evaluate that vector q in its cylindrical system. Now here we have to evaluate that vector q at point t, which is of 0, -4 and 3 in cylindrical system. Now if you carefully observe for your that point t, it is expressed in terms of rectangular system 1. So we have to convert that rectangular system into cylindrical system for that point t. So we have to convert that into cylindrical form. And what is that cylindrical form or cylindrical conversion from Cartesian to cylindrical one? So we have that rho, which is what? Square root of x square plus y square, and that will be what now? So rho we will have square root of x. So x value we have here 0 and y is what? -4 square. So that will be what now? 0 square plus -4 square. So your rho will be what now? Rho is equals to 4. Square root of -4 square is 4. Then next we have for cylindrical system phi component. So what is that phi component? That is tan inverse of y by x. See, this is the most tricky part of this numerical. Why? Because we have that phi is equals to tan inverse of -4. We have that y to be -4 and x is what we have. X we have that value to be 0. Now what will be your answer if you calculate it on your calci? So we will find that phi is equals to infinity, isn't it? But here we are not going to consider that phi to be infinity. Why is that one? Because we have to take some angle over there. Now if you go onto your basic coordinate system, what we have that your x and y. So this is your x-axis, which is +1. This is your y-axis, which is +y. We have this over here, which is minus of x, and we have this y to be a negative value. Now if you carefully observe, which is for your that y value, what is that y value over here? We have that y to be a negative value, isn't it? So we have that y value to be a negative value. Now where it will lie onto your y-axis? So it will be say somewhere around over here. So you will have that y value to be onto the negative y-axis. Now if you look out for your quadrants, so what will be the angle for this plus x? So that will be 0 degree. Angle for your plus y will be what now? Plus 90 degree. Angle for your minus x will be what now? Minus, sorry, that will be 180 degree. And for your minus y, so that angle will be what now? 270 degree. And again for your plus x, it will be what now? It will be 360. So from this we have that for negative y value, that can be anyone. So that can be -1, -2, -3 and so on up to infinity. So if you have that minus y value to be a negative value, so we have to consider that angle to be what? A 270 degree. So that's why we are going to take that phi to be a 270 degree over here. Well, I hope you have got this clear. Okay, so we have that phi to be a 270 degree. So we are going to put that value, and then next, so for cylindrical system and Cartesian system, z is as it is. So we have that z value to be what now? 3. Okay, fine. Now we have expressed that point T in its cylindrical form, which is of 4, 270 degree and 3. So this is your point T in its cylindrical form. Fine. So this is the very first part where we have to express that vector q in its cylindrical form. Now next is what? For this, in order to evaluate that vector q in its cylindrical form, we are going to make use of the earlier calculations or earlier expression that we have found that vector q in its cylindrical form. So what was that vector q in its cylindrical form? You can refer to that video that I have given in the description box. So vector q we have expressed in its cylindrical form to be what? Rho divided by square root of rho square plus z square. Then within that bracket what we have? We have that to be a cos phi a rho minus sin phi a phi minus z sin phi a z. So this is what we have found out in our previous videos, and this is what they are expecting us from us. Okay, so now you just place that values of that rho phi and z. So we have that rho to be what? 4 divided by rho square is again what? 4 square. Z is what? We have that to be the 3 square. Okay, then within that bracket cos phi. So phi value we have that to be the 270 degrees. Now you just place that values over there. So we have that cos of phi a rho cap minus sin of phi. So sin phi we have that to be the 270 degrees a phi. Z is again what? We have that z to be a 3. Then sin of phi. So phi is again 270, and this is a z cap over here. Now simplify that one by using your calc. So I have the answer, and from this if you are going to calculate that one, so you will find that vector q to be 4 divided by 5, and within that bracket we will have, okay, so cos of 270. So cos of 270 is what? We have that to be the 0 into a rho. Then sin of 270 is what? That will be minus 1 into a phi. Then minus 3, again sin of 270 is what? Minus 1 into az, and then next is what? 4 divided by 5. So your very first time it will get vanished, since we have that 0 into arrow, which is to be 0 minus 1 into minus 1. So that will be a plus 1. So that will be plus of a phi plus 3az. So your ultimate answer will be vector q in its cylindrical form to be 0.8 a phi plus 2.4 az. Okay, so this is your final answer, that we have evaluated that vector q in its cylindrical form. So very firstly we have converted that given point t in its cylindrical form, and then we have made use of this vector q that we have found out earlier in our previous video. Okay, so now we will move on to the third part of the numerical. Now we have to evaluate that vector q at point t in its spherical system. So again, if you see this point t, which is expressed in terms of Cartesian system, now we have to convert that Cartesian coordinates into spherical one. So for that purpose we are going to make use of some expression that we have discussed earlier. So in order to convert that spherical that Cartesian system into spherical one, we have to make use of that r, theta and phi expression. So what is that one? So we have r is equals to what? Square root of x square plus y square plus z square. Now put the values of that x, y and z within that values. Okay, so x square is what? We have 0 square, y is what? Minus of 4 square, and z is what? That is 3 square. Okay, so we have that. If you are going to simplify that one, so r, you will find that r is equals to what? 5. So this is your very first coordinate. The next is what? We have r, sorry, not 5. We have that is to be theta. So theta is what? Theta is cos inverse of z upon r, and cos inverse of that z we have that to be the 3, and r that we have found out earlier, so r will be 5. R is 5. Sorry for my handwriting. R divided by z, which is, sorry, z by r. So that is cos inverse of 3 by 5. And if you are going to evaluate that one, so you will find that theta is equals to what? 53.13. I have my answers. Okay, so we have that theta to be this one. Now next is we have to find out what is phi. So reference of this phi is from the previous conversion. We have that phi is equals to tan inverse of y by x, which is tan inverse of minus 4 divided by 0. So you will find that value to be infinity, but in its negative direction along y-axis. So that's why we can take that phi to be a 270-degree value. Okay, if you haven't got this concept, you can pause this video and revert it back up to that point. I'm not going to explain it again over here. Okay, so we have that r theta and phi for its point T, which is 53.13 degrees and 270 degrees. Now we are going to make use of the equation that we have found out in the previous video. We have evaluated that vector q in its spherical form, which was what? I have given the link in the description box. So vector q in its spherical form that we have expressed by using this expression, that is sin theta cos phi minus r cos square theta sin phi ar cap plus sin theta cos theta sin theta cos theta cos phi plus r sin theta sin phi a theta minus sin theta sin phi a phi cap. So we are just going to put the values of that theta and phi within the same expression, and then we are going to evaluate that one. So you can skip this part if you want, because simply we are just going to put the values of that theta and phi, and you can directly jump onto the final answer, or else you can stay over here. So I'm going to solve it for you by putting that values. So what is that theta? 53.13. Cos phi is your 270 minus r. So r we have that to be the 5 cos square of that 270 again sine of 53.13 degree. So this is the very first bracket for that AR, then plus sine of 53.13 cos of 53.13 cos of phi. So phi is what we have, that will be the 270 plus r is 5 sine of 53.13 sine of phi. So phi is again 270 a theta minus sine theta. So theta is what again? We have that is to be 53.13 into sine of phi, which is 270 into a phi cap. And you just make use of Cassie and simplify that one. So I have direct answer with me. You can verify. Okay, so from this we can find out that vector q in its cylindrical form to be 1.43 AR cap minus 1.91 A theta cap, sorry, 1.91 A theta cap plus 0.8 A phi cap. So this is the value for your vector q in its spherical coordinate system. Okay, so with this we have simplified part C of your practice exercise 2.1. Okay, now see you in the next lecture. If you appreciate my efforts, please do hit the like button, share it with your friends, and do subscribe my channel for upcoming videos. Okay, thank you.